In this example, a cyclist rides in a straight line for 20 minutes. She waits for half an hour, then returns in a straight line to her starting point in 15 minutes. This is a displacement time graph for her journey. For part A, work out the average velocity for each stage of the journey in kilometers per hour. So for part A, we say the journey from 0 to A equals in time. So the time will be approximately 20 minutes, and in terms of the displacement, it will be 5 equal 5 kilometers. So for us to find the velocity, v will be displacement over time. So that will give us, as shown on the right hand side, so that will give us the velocity to be equal in this scenario 5 divided by 20, and that would give us 0.25 kilometers per hour. Now in this scenario, because we are given in per minute, now we need to convert from kilometer per minute to kilometer per hour. So for us to do that, we will have to multiply the 0.25 by 60, because and in this scenario that would give us 15 kilometers per hour, which will be the answer for part A. Now, and also we need to think about the journey from B to C. So in this scenario, the time is equal to 15 minutes, which is between 20 and in this scenario between B and C, which is 50, and because we are stuck in between of 60 and 70, so we say it's 15 minutes. Now in terms of the displacement in this scenario, will equal, because it is getting reduced, so be minus 5 kilometers, as it is coming back to 0, and the average velocity will be distance over time in this scenario. So we would have minus 5 over 15, and that would give us minus a third in terms of kilometers per minute. And now if we want to change it to hour, that would be, so say kilometer per minute, we change it to kilometer per hour, so that will give us minus a third multiplied by 60, so that would give us in this scenario minus 20 kilometer per hour. So that will be our answer for part A. For part B, we need to explain, we're asked to write down the average velocity of the whole journey. So for the whole journey, because it goes from 0 to 5 and it continues and then returns to 0, so displacement, so the velocity whole will be equivalent to 0. And so this will be our answer for part B. For part C, we need to work out the average speed for the whole journey. So for part C, we say the total time equals 65 minutes, and we know the total distance is 5 and then 5, so we say total displacement will equal, in this scenario, the distance will be actually not displacement, however we say that distance will be 5 plus 5, so that will give us 10 kilometers in terms of the total distance traveled. So in this scenario, we will get the velocity to be distance over time, so that will be 10 divided by 65, which will give us 2 over 13 kilometer per minute. And now if we want to change it from kilometer per minute to kilometer per hour, we would have the 12 over 13 multiplied by 60, so that would give us approximately 9.2 kilometers per hour, which will be our answer for part C. In this example, this is a displacement time graph for a car traveling along a straight road. The journey is divided into 5 stages, labeled from A to E. For part A, work out the average velocity for each stage of the journey. So first we look at, so for part A, we look at, so we say the displacement A, that will be 40 kilometers, and the time will be 0.5 hour. So in this scenario, the velocity will be velocity A will be d over t, so that will be 40 over half, so that will give us 80, so it will be kilometer per hour. So that's for the journey of A. For B, so that's for A. For B, so the displacement will be in the scenario 20 kilometers, and the time will be half an hour, so that will give us the velocity to be 20 over half, so that will give us approximately in this scenario 40 kilometers per hour. For part C, so we have the displacement to be 0 kilometers and the time to be in this scenario 0.5 hour. So the velocity will be in the scenario 0 over 0.5, so that will give us 0 in the scenario kilometer per hour. So we have 80, we have 40, we also have 0, and now we look at D. So the displacement, it will be in the scenario 40, and the time to be in the scenario 1 hour. So we would have the velocity 40 over 1, so that will give us 40 kilometers per hour. Now for part E, we have the displacement to be minus 100, and the time to be in the scenario 1.5 hour. So the velocity will be in the scenario 100 over 1.5, so that will give us approximately, because it's negative, so it'll be minus 66.7 kilometer per hour. And this will be our whole journey from A to B to C to D to E. Now for part B, we need to state the average velocity for the whole journey. So in this scenario, because it starts from 0, travels and it returns to 0, so we say velocity of whole will equal 0, return in this scenario 0 kilometers per hour as it returns to a stopping point. And this will be our answer for part B. For part C, we need to work out the average speed for the whole journey. So in this scenario, we add the total distance. So we say distance total that will be, in this scenario, we add it will be approximately 200 kilometers, and time total, that will be approximately 4 hours. So the velocity will be distance over time, so that will give us 200 over 4, so that would give us 50 kilometers per hour. So this will be our answer for part C of this question. In this example, Khalid drives from his home to a hotel. He drives for 2.5 hours at an average velocity of 60 kilometers per hour. He then stops for lunch before continuing to his hotel. The diagram shows a displacement time graph for Khalid's journey, and for part A we need to work out the displacement of the hotel from Khalid's home. So for part A we need to find for the first section of the journey in terms of the displacement. So for the first section we would have in this scenario we know the velocity is 60 kilometers per hour. So, and we know the time has taken approximately 2.5 hours. So we are given this information in terms of what it takes. Now for us to find the displacement, so we say velocity is then distance over time. So we know we have the velocity is 60. We need to find the distance, and we have the time to be 2.5. So that will give us the displacement to be 150 kilometers, and this will be our answer in terms of the displacement for part A. Now if we want to find this is 6 squares on the vertical axis, so you can see here, and for us to find, so say this is 6 squares on the vertical axis. So 1 square is 150 over 6, so that will give us 25 kilometers. So total displacement in this scenario shows as 7.5 squares, so it will be 7.5 multiplied by 25, which will be equivalent to 187.5 kilometers. So this will be our total displacement representation for the of the hotel from Khalid's home, and this will be our answer for part A. For part B, we need to work out Khalid's average velocity for his whole journey. So we need to assume that time for the whole journey will be equivalent to 3.75 hours. And in this scenario we said that velocity will be equal to displacement over time. So for us to find velocity we have 187.5 divided by time, which is 3.75, and that will give us 50 kilometers per hour, and this will be our answer for part B of this question.